Now, a lot of times you're going to need to factor in calculus. Here are the standard methods you were taught in pre-calculus. Pulling out a common factor, a difference of squares, a perfect square with a plus or a minus, a sum of cubes, a difference of cubes, or grouping. There's another method I would like to show you, and I will show you in the summer class, and that is the area model. And I think the best way to show that is with the sum of cubes. Suppose I have x cubed plus y cubed. And you're going to get this on the first test, I promise you. And you're going to forget how to factor this. So I'm going to tell you that one factor is x plus y. And you want to end up with x cubed, and I know I'm going to need an extra one here, and y cubed. And basically what we're going to do is, like the area of a rectangle, we're going to try to find this area. Now, this is x plus y, and this will be whatever we wind up figuring out. So x times what is x cubed? Well, x squared times x is x cubed. All right. So x squared times y is x squared y. But I don't have any x squared y terms, so I know this has to be minus x squared y. All right. X times what gives me minus x squared y? So this is minus x y. So minus xy times y gives me minus x y squared. But I don't have any x y squared terms, so I need to add x y squared. So this becomes x times what gives me x y squared, and of course that's y squared. So if I look at this as an area where I have created this area right here, what is this area in here? This area is x cubed minus x squared y plus xy squared plus x squared y minus xy squared plus y cubed. What am I left with? That goes away, that goes away, x cubed plus y cubed. So this is the area model. But what does that tell me my answer is? This x cubed plus y cubed becomes x plus y times x squared minus xy plus y squared. And this is, I'm going to pop back, the trinomial that we have found is unfactorable. And it turns out you can use this area model throughout most of these problems. Now for this one you don't really need it. Suppose, what do I need to factor out here? I know there's a common factor of 2a. So 2 out of 4 is 2a plus 1. And this is completely factored down. There's no more I can do. What about x squared minus 2? Let me use my area model because I think it's kind of fun. X squared, now 2 by 2. This is negative 2. Now this is a difference of squares, isn't it? All right, so a difference of squares. All right, what two numbers multiplied together give me x squared? Well, that's just going to be x. What two numbers multiply together to give me negative 2? Well, this one's a negative, so I'm going to need a square root of 2 and a minus square root of 2. Now this is just a logic I'm using, so let's look at this. This one's going to be x times what is x squared, so it's going to be x times x is x squared. X times the square root of 2 is x times the square root of 2. X times minus the square root of 2 is minus the square root of 2 times x. And negative square root of 2 times the square root of 2 is minus 2. Cool. So when I add the areas up, I've got x squared minus the square root of 2x plus the square root of 2x minus 2. So this is x squared minus 2. I know this seems like a long way to say that this factors into x plus the square root of 2 times x minus the square root of 2. Now, what if we have a function like this? Y is x to the fourth, y is, or 5x to the fourth minus 5y to the fourth. Factor the 5 out first. Now, this is a difference of squares. So this is 5 times x squared minus y squared times x squared plus y squared. This is not factorable, but this one is. So this is 5 times x minus y, x plus y.